The valet key pattern is a pattern wherein a user connects to your application, and rather than your application directly serving some kind of binary data, instead gives a token that allows the user or the client of your application to directly pull that data. Right? And if you think about any application, applications are always serving up data that's being stored somewhere else, or almost always are, right? The user connects to your database, they want a product list, or to your database, they connect to your application, they want to get a product list, your application goes to the database, gets the product list, and returns it to the data. There has to be some processing to that, right? And it makes sense to go through the application for that. But what if a user just needs an image, or needs a video, or needs a document? Right? It doesn't necessarily make sense for the user to send the request to your application go and get the binary, not do anything with it, but simply serve that binary up. What makes more sense is for your application to redirect the user. The problem is that unless that's a public domain and anonymously accessible resource, file, image, video, whatever, then there has to be some way of controlling access to that. And that's where the valet key pattern comes into play. And the idea is pretty simple. You don't want to make your resources publicly available, right? So you have your application validate the client, right? And then after you validate the client, instead of returning the actual binary data, you simply return a token, and then the client uses that token to retrieve the resource directly. And this works great, for example, for web-based applications. Let's actually take a look at this in a little bit broader scale, and I'm going to subject you to my screen drawing ability. Okay, so let's say that I've got a user over here, right? And users like hats, right? And I've got my application, and I also have a bunch of files over here, right? So here's my app. And let's say we've got a bunch of images, but these images need to be protected, right? And so I need to control access to those images. Well, one thing, of course, that I could do is the user could come in here to the application could go retrieve the image, pull the image back, process that, and send those binaries over to the user. But that's going to be really inefficient. That's a big, a very large load that's being added to the application, right? What's going to make more sense is if the user connects to the application simply develops a token, that's a token, kind of best I can do, sends the token back to the user, right? Then the user takes that token, right? Oh, and by the way, that token is also understood by the image storage system. So the user takes that token, and that token then provides access so that that image is returned directly from the image store to the user. And that is such a common and important pattern that it's actually baked directly into Azure and Azure storage through something called shared access signatures. I can have an application develop a temporary, what's called shared access signature token. That goes to the client. The client can then go directly to that stored binary resource, and it bypasses the application for what can be a fairly significant part of the load of the overall application. So this is something that in so many different instances, if you've got data that doesn't need to be processed by your application but does need to be controlled by your application, it does need to be secured, this is a pattern that you absolutely want to think about implementing within your application.